All right, this is the second part of lesson 431. We're going to learn how to solve equations that have a square root in them, or squared equations. So we're going to learn how to use the square root to undo equations. But as you were doing the exercises in class yesterday, you probably ran into this and were a little bit confused about it, so I'm going to just talk about that for a second. It says, consider the value of, I'm just going to go back here and just write down our answers so we can think about this for a second. So one thing I want you to notice is that all of these answers are positive. So with that one, what we're saying is, so assume n is positive, so we're looking at this problem and this problem. Write an expression equivalent to the square root of n squared. And notice we get exactly the same number as the number we're squaring inside that. So that means n, the square root of n squared is equal to n. Exactly the same number. Part B says assume n is negative. So now I'm going to change colors here so we can see that. Right here, notice n is negative number there and there. But notice that when we do it, we get a positive number. So it says write an expression equivalent to the square root of n squared. And that, notice, somehow we have to get the opposite of what we had. So let's say, so this n is negative. The opposite of that would be a positive. But to show that, I need to show that I'm getting the opposite of what I got. And to do that, we can just put a negative in front of it. So basically what we're saying here is that this means the opposite of n. Okay, now C says, if possible, write a single expression equivalent to the square root of n squared that has no radical signs for any value of n, positive, negative, or 0. So looking at all of these results, no matter what number we have underneath the square root, it turns out to be a positive number. So we're thinking back to, is there something I can do that will turn negatives into positives and leave positives positive? And it turns out there is, and if you remember, it's called the absolute value. And so the square root of n squared equals the absolute value of n. Then we don't have to worry about whether it's a positive or negative, because the absolute value of n turns it into positive. All right. So this talk about this here. Why are absolute values needed to write the square root of n squared as a single expression that has no radical sign? Because if n is positive like this, then the square root of 3 squared is the same exact number as the base there. But if we have a negative like this, then when we do the negative 3 squared, we get positive 9. So that's actually the same as this, which is positive 3. And notice that my original number was negative, but when I simplify it, I get a positive. So we use the absolute value of n, so we don't have to worry about whether n is negative or positive. All right. Let's do a couple of these now. So it says solve these equations if possible using whatever method you prefer. If an equation has no solution, write no solution and explain why. Some of these I think we can just think about the answer. Okay. Let's look at number 23 here, and I'll write it over here. So basically we're saying here is the square root of what number is 7. And one thing that we can do is certain numbers we know that the square root of 49 is 7, so we know x to be 49. Okay? And if I want to show my work on that one, if I square both sides, thinking about what you just learned there, the square root of x squared, as long as x is a positive number, and x has to be a positive number, otherwise we can't take the square root of it. Then the square root of x squared equals x, and if we square this side, we get 49. So x equals 49. Let's do a problem like number 25. Square root of x plus 8 is equal to negative 6. Well, to figure out what this part, the square root of x, has to be, let's get rid of this plus 8. So I'm going to subtract 8 from both sides. And then I get the square root of x is equal to negative 6 minus 8 is negative 14. Okay? So the square root of what number is equal to negative 14? Well, I hope some of you are thinking that, you know, when I do this square root, it always ends up positive. So how am I going to get a negative 14? And that's true. There's no number that you can, when it says the positive square root of x equals negative 14, that is impossible. So there's no solution. If it said this, the negative square root of what number equals negative 14, then we could figure that out by just multiplying 14 times 14, which is 196. And we could say that the negative square root of 196 equals negative 14. That would be true. But as it's written, since it has to be a positive number, there is no solution. We can't get a negative number. All right. Let's look at number 27. Square root of x plus 2 is equal to 5. All right, now some of you might be thinking, just think in your head, that, you know, what number, square root of what number equals 5? And some of you may be thinking, well, I want this thing to equal 25, because the square root of 25 is equal to 5. So then you're just thinking, well, what number plus 2 is equal to 25? And that number is, just subtract 2 from 25 and we get x equals 23. That's one way you could solve it. Another way is, if I do this, if I square both sides of this, so 5 squared, well 5 squared is 25, right? And if I take the square root of some number and square it, I get that number inside. So I end up with the same thing. And then I can solve that and I get my answer is 23. All right? And let's do one more, and then I'm going to let you try and do the rest on your own. But I'll do number 29. So we have x squared equals 64. So basically we're thinking what number multiplied by itself equals 64. Now some of you are thinking, well, I know that in my head, that's 8, right? But there's actually two numbers that when multiplied by themselves equals 64. So you have to remember both of them. And the answer is 8 and negative 8, because negative 8 times negative 8 is also equal to positive 64, and 8 times 8 is equal to 64. Now, one way we can solve this by using properties of equality. I know that the square root of x squared is equal to the absolute value of x. And I put that there just to make sure I keep my number positive. And that's equal to, the square root of 64 is just 8. And so right now I'm thinking, well, what number can I take the absolute value of and get positive 8? And there's actually two of them. X can be 8 and x can be negative 8. And just to show the kind of problem I'm talking about there, I'll just do one more example here. If I say that the absolute value of x is equal to 5, and one of the ways you learn about absolute value is it's the distance from 0 on a number line. So really what I'm saying here is what numbers are 5 units from 0 on the number line? Well, I can go 5 units this way or 5 units that way. from 0. If I go 5 units to the right, I'm at 5. If I go 5 units to the left, I'm at -5. So there's two numbers that I can put in here for x and take the absolute value of and get 5. All right. So let's do number 6 here, and then I'll let you do the rest in class. So we start with this equation, the absolute value of the quantity x plus 3 equals 8. First thing we did is we squared both sides. And what that does is it gets rid of the square root. You square a square root, it undoes that. So now we have x plus 3 equals 64. And that's just simplifying that. And then, to get 61, you probably are thinking, oh, they subtracted 3 from 64. So yeah, that's the subtraction property of equality. And you get the answer, 61. All right, that's it. We'll see you tomorrow, and we'll work on some of this in class.